Hello everyone, welcome to this session of coordinate geometry. So our current topic is straight lines. All of you know the importance of coordinate geometry. Mainly here, it provides the relation between the geometry and algebra. It uses or extends to every field. You can use the geometry in physics, chemistry, calculus, trigonometry. You can use everywhere. And at the same time, in geometry there is one advantage. We can draw the figure with respect to the given data. If you have a figure in front of you, just it is easy to observe the problem and analyze and recall it. To get the idea, it is very easy if you have a figure. Okay, and at the same time, straight lines, it is a very, very important topic. It is just like backbone to the geometry. Understand? Straight lines is just like backbone to the geometry. It is useful in every corner of the geometry. Whatever be the topic, ellipse, parabola, hyperbola, pair of lines, 3D, whatever it may the topic. Throughout geometry it is very, very useful. You can use these straight lines. So straight lines is very, very important. So concept, if you have clear idea about what is straight line, what are the requirement to write the straight line, what are the forms of the straight line, those are the very, very important. Okay, now first of all I want to introduce what is the meaning of the straight line, what is the definition of the straight line. In general words, how can you say what is straight line? That is the important thing. So see here, now say this definition of the straight line. Generally there is no definition, but there is a meaning for the straight line. So generally you can say, for illiterate people also can understand this one. The shortest distance between the 2 points, that means the path which is used to find the shortest distance between 2 points is simply straight line. If suppose take 2 points on the plane, you can draw the lines or curves from first point to second point infinite number of ways. The only one path gives minimum length from A to B. The tracing path is simply represent a straight line. So in other words, the graph which have no curvature, listen to me, the graph which have no curvature with a fixed direction and having the shortest length, shortest distance is called a straight line. It is the curvature, there is no curvature for the straight line and having a fixed direction, the length is minimum. In case of that graph represents a straight line. Otherwise, shortest distance between the 2 points. Suppose take 2 points on the plane. Suppose these are the 2 points A and B. Here I have to introduce the definition of this straight line. Okay, so we can reach A to B in infinite number of ways. This is the one of the way, this is the another way, this is the another way, so this is another way. So many ways you can draw from A to B, so many lines you can draw. But this is the line only have minimum length when compared with the others. We can't find out the other line which does not have the length having less than this length. Clearly this dotted line have minimum length. We can't find out other line which have less than this length of the. Okay, now clearly this length is tracing this path is called a straight line. Understand? We can draw infinite number of lines from A to B. Here this have a direction and having the shortest length, there is no curvature in this. So clearly this is a straight line. This is the way how to introduce straight line, represent straight line. Understand? These are also lines, but these are not called straight lines. This is called straight line. We can't find out another line which have the length less than of this AB line. Understand? Generally, the line AB is denoted by like this. So the line segment AB is denoted like this. Ray AB denoted like this. There are slight variations. This represents a straight line. This represents the line segment AB. This is the ray from A to B. Okay. So now I want to discuss straight lines. The first concept in straight lines is inclination of the line. The inclination of the line is nothing but an angle. The angle of inclination of the line is measure of the angle between the x-axis and the line measured in the anti-clockwise direction. Observe this figure. Here theta is the angle made by this line. Here this is a positive x-axis. If you measured in anti-clockwise direction, then only this is called the inclination of this line. Understand? Here theta is the inclination of the line. Okay. Now observe this next one. So here observe this figure. Here these two lines are parallel. When the two lines are parallel, the angles made by these two lines with the x-axis is same. All of you know. Here when the two lines are parallel, they have the same inclination. If you take any two lines, anywhere, the two lines are parallel, their inclinations are same. Next. The inclination of a line which is parallel to the x-axis. What is the inclination of a line parallel to x-axis? Just to observe that. Suppose this is the coordinate system. Here this is x-axis. If you take any line parallel to x-axis, suppose this is the line. These are the lines which are parallel to the x-axis. The inclination of these lines, that means the angles made by the line is with the x-axis in anti-clockwise direction. Here there is no angle. Here in case of all these lines are parallel to x-axis. Inclination of any line parallel to x-axis and x-axis is 0. Okay. Next, see. Here the inclination, what is the range of the inclination? If you take any line 0 to 180 degrees, the inclination of a line lies between 0 to 180. So you can't find out the angle greater than 180 degrees for a line. Here the direction is not important. This angle made by the line with the positive direction of x-axis measured in anti-clockwise direction is called inclination. See, observe this. Here, suppose this is the line. This is the inclination. If you change this direction, suppose this is second position, this is the inclination. This is the third position, this is the inclination. This is the fourth position, inclination. This is the final position, this is the inclination. This is the maximum inclination is this one. That means inclination always lies between 0 to 180 degrees. Okay, inclination means the angle made by the line with the positive direction of x-axis measured in anti-clockwise direction. Simply, angle made by the line with the positive direction of x-axis. That is called inclination. Next, slope or gradient of the line. This is an important concept. So now see the definition of the slope of the gradient of the line. Now see, if the inclination of the line is theta, for non-vertical line we can define slope. Here theta is an inclination of your line, theta is not equal to 90. Then tan theta is called slope or gradient of the line. Here this is the figure. In figure here the line is making an angle theta. Now the slope of this line is nothing but tan theta. Tan theta is slope of the line. Understand? If theta is the inclination of line, tan theta is called slope of the line, and at the same time slope is denoted by m. Slope of the line, otherwise gradient of the line. Gradient, slope, both are meaning same. Gradient of the line and slope of the line is equal to m is equal to tan theta. That is the slope of the line and the theta is inclination. Okay, observe that. Slope of a line, not the angle, is the tangent of the inclination of the line. Slope is not meaning of angle. Tangent of the angle is the slope. That is the one important thing. Next one. If a line is parallel to the x-axis, what will happen? What is the slope? If the inclination is theta, tan theta is the slope. Here observe that the line here, this is parallel to x-axis. If you know the inclination, then only you can find out the slope. Okay, here this is the line parallel to x-axis. Its inclination is 0. Slope is tan 0, that is equal to 0. Slope of any line parallel to x-axis is 0. Slope of the x-axis also 0. So observe that if the two lines are parallel, if and only their slopes are equal. Since for parallel lines inclinations are same, if they know the inclinations by applying the tan, we can find out the slopes. Here these two lines are parallel lines. Let us consider the inclination of these two lines are theta 1 and theta 2. Okay, for their slopes you have to apply tan. So for parallel lines, theta 1 is equal to theta 2. Theta 1 is equal to theta 2. Just apply tan on both sides. Tan theta 1 equal tan theta 2. Tan theta 1 is nothing but slope of the first line m1. Tan theta 2 is nothing but slope of second line m2. If the two lines are parallel, slopes are equal. Slopes are equal. If the two lines are parallel, slopes are equal. M1 equal to M2. For parallel lines, slopes are equal. If the slopes are equal, lines are parallel. Okay, now come to second point. If two lines are perpendicular, if and only if their product of slopes equal minus 1, we have to prove this relation. So for that, consider two lines. Clearly these two lines are perpendicular lines. This and this are two perpendicular lines. Let us consider theta 1, theta 2, the angles, inclinations made of these lines. Then slopes of these lines are m1 and m2. Let us consider okay, right. Let us consider m1 be the slope of the first line, that is equal to tan of the inclination of this line, tan theta 1. And similarly, m2 be the slope of the second line, that is equal to m2 be the slope of the second line, that is equal to tan of inclination of the second line. Okay, these are the relation between slopes and inclination. Now observe the figure. Sum of the internal angle equal to external angle. That means theta 1 plus 90 is equal to theta 1 plus 90 equal to theta 2. Therefore, theta 1 plus 90 is equal to theta 2. This is the relation from the figure. So you have to find out the relation between slopes. Slopes are nothing but tan theta 1. For that, apply tan on both sides. So here, tan of theta 1 plus 90 is equal to tan theta 2. Okay, so tan of 90 plus theta minus cot theta, that means minus cot theta 1 is equal to tan theta means m2. We have to write down in terms of m1, m2. m1 is nothing but 1 by tan. That means here cot is nothing but 1 by tan. So m1 is nothing but tan theta 1. Here cot theta 1 is there. So write down minus 1 by tan theta 1 is equal to m2. Now tan theta 1 is nothing but m1. Minus 1 by m1 equal to m2. This implies minus 1 is equal to m1, m2. This is the relation between slopes of the two lines when the lines are perpendicular. Here the two lines are perpendicular. Slope of the first line is m1, slope of the second line is m2. Therefore their product of slopes equal to minus 1. If suppose slope of the second line is m2, slope of the first line is m1, then from this we can write m1 is equal to minus 1 by m2. Otherwise m2 is equal to minus 1 by m1. These are the relations between the slopes of the two lines when the two lines are perpendicular. These two results are very, very important. If the lines are parallel, their slopes equal. If the lines are perpendicular, product of their slopes equal minus 1. Simply, that's it. Just only 2 points. Slope of the parallel lines equal. If the lines are perpendicular, product of their slopes equal to minus 1. Okay, come to next concept. Next, intercepts. What about the intercepts? What are the intercepts? So see the figure. Here this is the line intersecting the x-axis at A and y-axis at B. X-axis at A and y-axis at B. Here the length from origin to A, this part, this length is called x-intercept. the length of the intersecting point from the origin on x-axis is called x-intercept. Here this length is called y-intercept. This is the line intersecting point. Here B is the intersecting point on y-axis. The distance from origin to this point on y-axis is called length of the y-intercept. Here this is called x-intercept. This length is called y-intercept. This A point is called x-intersect. B point is called y-intersect. Don't get confused. This length is called x-intercept and this length is called y-intercept. If a line cut the x-axis at A and y-axis at B, okay, then the length OA and OB are known as the x-intercept and y-intercept. Okay, now here observe one thing. Here OA, the length always positive, but intersecting may be negative. X-intercept may be negative sometimes, but length case point of view, we have to write positive value. So here this is nothing but mod A. Mod A represents the length of the intercept. Mod A represents length of the intercept on the x-axis. Here mod B represents the length of the intercept on y-axis. Understand? So intercept of line x-axis may be positive or negative. Intercept of a line on x-axis or y-axis may be positive or negative, but length of the x-intercept and length of the y-intercept are always positive. So you have to take modulus value. The length always positive, you remember it. X-intercept, y-intercept may be positive or negative. That depends upon the coordinates. If suppose the intercept is in first quadrant, what will happen? Positive x-axis, positive y-axis. This is the first quadrant. Both are positive. So this is the line intersecting at A and B. Let us take A and B. Here this length is OA is called x-intercept. Here it is positive. It is positive. Now if the length is A, then coordinates of point A comma 0. If the length is B, now the coordinates are point 0 comma B. Okay, it is in the figure in the first quadrant. If suppose the line intersect the coordinate x in second quadrant, if the line is in second quadrant, so this is the figure. Negative x-axis, x dash, positive y-axis. This is the position of the line intersecting second quadrant. Here this length magnitude be A. Now the coordinates of this point A minus A comma 0. Just observe this. The coordinates of this point is negative, minus A comma 0, but length be positive. Here if this length is B, now the coordinates of point is 0 comma B. Clearly this is a line intersect the coordinate x in second quadrant. X coordinate is negative, here positive, but length always positive. If suppose observe in third quadrant, what will happen? This is the position of the line intersect the negative x-axis and negative y-axis. So let us consider this is x dash, this is y dash, this is x, this is y, this is origin. Here the length x-intercept A and y-intercept B. Now the coordinates of this point minus A comma 0. X-intercept is negative in third quadrant and y coordinates of this point 0 comma minus B. Length always positive, intersect may be positive or negative. So similarly observe in the fourth quadrant, what will happen? This is the position of the line. The length A, this length B. Now the coordinates of this point A comma 0, coordinates of this point 0 comma minus B. This is the way how to find the coordinates of the point, intercept point on x-axis and y-axis with respect to the quadrants. Okay, intercepts may be positive or negative, but length always positive, remember it. Okay, so see these figures again.